Boom. And where are you? Let me grab Slack and just copy and paste this array in here for us. Cool. So in this array of our a collection of Kardashians, I have never seen the show, and I feel from all that I've heard, I don't have any inclination to see the show. But clearly their parents, I assume, have decided that, like, hey, let's have a theme with naming our kids. I think that parents who do that are cruel. I had a friend once whose name was Chris Christensen. I'm like, do your parents hate you? Obviously, the answer is yes. And so we want to grab all the Kardashians' name is longer than 3 letters. So look at this real quick, I can see that Kim's the only one here. And if we start the basics and we just use .each, what we can do is I'm just going to make this empty array here called collection, and we're going to set equal to an empty array. And what I'm going to do is I'm going to iterate over the Kardashians. Iteration is going to be our generally our choice kind of technique when we have to do something to the entire contents of an array or some other collection. So Kardashians.each do, let's do person. I don't want to type Kardashian again. And I want to go ahead and I want to put into the collection enumerable their name if it's longer than however. And so we do if person length, because person is going to be string, that's her name, is greater than 3. I always have to look at it again to make sure that that's the right thing. The big side goes towards the bigger thing. Cool. Collection. I'm going to shovel in person and here we're just going to do puts collection.
Here are your top Amazon deals.
Computer, stop.
Pressure air fryer.
Oh my God.
It's $149.99
Shut up.
on Amazon.
Shut up.
After $50 in savings.
Stop.
Would you like to add it to your cart?
Oh my God. Yeah, so I just turned off the microphone on my Alexa. It's right next to my computer.
Would you like to add it to your cart?
No. Okay. I've just muted it, so I think we should be good. Puts collection. What am I doing? It's totally just derailed me. Ruby, we're just going to run the file. And let me make this a little bigger for you so you can see. Cool. It's printed out Chloe, Chris, and Courtney. These the 3 ones that work, and like, yeah, we can see this, and like, this is kind of a thing. We can actually refactor this here. Like, if we have a conditional that just has one kind of branch where we do this or nothing, what we can do is that we can change this out and convert this to what we call a guard collection, a guard statement. Collection shovels in person if person dot length is greater than 3. Right, this is called the guard statement. The idea here is that if this side of the conditional returns as a true, like we talked about on Friday, this side is going to run. And when I share this and I run it again, we should get the same thing. Cool. So I guess at this point I want to pause if anyone has any questions or comments about the code I've written here so far, particularly like converting that one branch if statement into a kind of a guard statement. Any comments about that? All right. So I think I've mentioned this in classes before. In some of our check-ins that is that there's this pattern here of when we have a collector on the outside of an enumerable, and the enumerable just iterates over a thing, and the idea is that we want to have an array at the end. What we kind of want to do is that we want it it's a sign that we can use a better enumerable. The idea is that, like, why don't we just have this? Why isn't there a enumerable that just gives us what we want instead of having to find this, have this local variable set to a array outside, have things kind of push into it, and then we turn out it feels like kind of messy. So what we can do is that we know that what does each return? Anyone?
Original array.
Original array, right? And I said we don't want the original array. Like, we don't, for Kim, whoever that is, we don't care about Kim. Like, screw Kim, get Kim out of here. We just want a new array that has the stuff we want. So we can convert this to map. And the idea here is that I'm going to do collection equals Kardashians.map person. And the idea here is that I kind of want to focus in on is that Kardashians.map, when we map over something, whatever the return of the block is every single time we go through is going to be the contents of each array. So map to person if person dot length is greater than 3, was it? Yeah, 3. And we kind of run that there. But you might notice that, like, we have this blank spot here. And what we can do to get a little more information on what that blank spot is, we can throw an inspect on the end of this. Inspect is something that gives us what I would like to call a developer view. It gives a little, when you put something that's inspected, it gives you a little more information about what's happening. Let me do this. I'm going to throw a prize session. Let's have a string called string, and we're going to put hello in there. Right, and we see that the string local variable contains a string hello. If I do just puts string, it prints out hello. But if I do puts string.inspect, we see that it prints it out including the quotation marks. The inspect method, when we call on something, gives us this value that gives us a little more detail so we can intuit what's happening a little better. The same thing here. 1, 2, 3. I'm going to set this equal to an array. And if I do puts array, we just see 1, 2, 3. Now, if you were to see this printed out 1, 2, 3, would you be able to tell, like, if this was a string and just had some, like, line breaks in it, or if it's an array? Like, you wouldn't be able to readily tell. So we can do a puts array.inspect, and you see it'll print it out with the brackets. This is kind of a useful thing to know when we're kind of debugging code. If we want to see, like, hey, is this actually what I want, or is it just something that kind of looks like what I want? And so if I do puts collection.inspect here, I can see here that I have an array with Chloe, Nil, Chris, and Courtney. And so I'm like, wait, why is there a nil? The thing is that what map does is that it brings us, it gives us this, it creates a new array where each time we go through a thing, it'll return to us in that position the contents of the return value each time we go through. Let me kind of walk through this step by step. So when we map over something, what we do is that we essentially are creating a new array with the same amount of slots that the original collection has. So we're creating an array that's that is 4 slots in size. The first time that goes through, person is going to return person length is 3. Chloe, the length of Chloe is longer than 3, so it's going to return person. So person takes the 0th slot in that array we're now creating. We go to Kim. Kim is Kim.length greater than 3. No, it's not. It is exactly 3. So this part doesn't get run. And if this doesn't get run, nothing gets returned from this part of the block. And when nothing gets returned, nothing here is nil. So this array index 1 or the second slot is going to be nil because nothing gets returned out of this block the second time through. We go back through. Chris is longer than 3. We return Chris. So the third slot of the array is Chris. We go through again. Courtney's longer than 3. And we get the Courtney's going to occupy the fourth and final slot. So it's very important to realize that like enumerables generally use the block return values to generate a new thing. Any questions about that? We will have some opportunity for you to practice like playing with return values in a little bit. Sean?
Oh, sorry. I was just curious. I was doing P instead of puts, and it's doing like an escape character or showing how that is, like all the backslashes. We should just do puts.
I generally just do a puts. P does, I think P is a combination of puts and inspect. Yep. P is a shorthand for puts and inspect, I think.
Oh, wow. Thank you.
Yeah. It's just, I just don't ever, honestly, I always forget that P exists as a thing. So yeah. I always do puts, and then if I need the inspect, I'll throw the inspect on the end of it. Cool. Are you okay?
Yeah, I'm wondering how to explain this. If you get an error that says given block not used, like say this was in a method, what?
I'm not sure, considering like without context of what you're doing
Yeah.
to cause that, and that's something I can't really comment about what exactly that means.
Okay, once I form it better, I'll
Okay.
ask again. Thank you.
Hey, Mike,
Yes.
is map the best enumerable to use? Like if we're like,
It
I'm
depends.
thinking, okay, so I was thinking about this like as like a find the name,
Yes,
so like
yeah.
find all type of thing.
We'll talk about that next. That's a good question.
Okay.
The idea is that they're like like I think that as we get more familiar with enumerables, like my usual process about working it is like I'll usually start with an each and like just get something working, and I look at them like, okay, is this something that I'd use map for? How do I want to do this? And then like looking exactly what I'm doing, I'll probably say like there's got to be something better for this. And like I think looking at this, we can kind of try to pick another one. And so we have this here and that. And we can use other ones. And like, for example, Dan was talking about find all. And I think that like knowing a find all, the great thing about numerals is that what they do always sounds like a lot like what it's named. So we're going to do collection equals Kardashians dot find all, do person. And how find all works is that it will give us an array of all the things that meet the block that the block returns true for. So what we're going to put here is person dot length is greater than 3. And so what it's going to make a collection of is going to collection of all the items in here where so long as the block returns true. And so when I run this, we should see that it has the Chloe, Chris, and the Courtney. Nico?
Sorry about that. Yeah, I missed the microphone. So I was wondering if you could do an example, or is it possible to use reduce to do this type of for this type of example? Or like I hear you guys talking about reduce a lot, and I was wondering.
We can. I'm not going to talk about that right now. Like I think that we want to start covering like more about the other stuff instead.
Got it.
We'll talk about reducing a little bit.
Oh, okay. Sounds good. Thank you.
Yeah.
Mike, I got a question.
Yeah.
Can you like describe a situation in which you would have like person if person dot length, like the way you originally had it? Like why would you want to do it that way instead of just the way you have it now?
You wouldn't? We're just walking through the kind of like, this is like how I generally kind of work. Like I work through the progressions. Like, okay, I get this to 1 point using each. And then I'm like, okay, like this feels like I should be able to do this. Let's find a better way. Right. It's very similar to that red-green refactor. Like as you get better and you remember more enumerables, you will start to like, they will be your first reach. But like when you're starting out, you're not sure, like it's perfectly okay to use each. It's just that we expect that like, as you get used to it, you'll like reach for it. Like, yes. Cool.
You know, Mike, when I tried this one with map, and then
Uh-huh.
instead of giving me the names, it gave me like true, false, true, true.
Right, because what map does is that it will give you the the return values, what's slotted in. This a condition like this will only return true or false statements. If you wanted to use map, you'd still have to return something explicit. You'd have to return the person if that whatever this is returns true or false. Right?
Okay.
This one, the way find all works is that it will return the object we're currently on in that iteration, so long as the block returns true. It will not add it if it returns false.
Got it.
But if you add, Nico, if you added that person.length with that map, then it will do the whole name, nil, name. But if you just do person.length, then it's only going to return the truthy falsies.
Got it. That's what I got. Yeah. Thank you.
So we have other stuff for funsies here. Like what if we wanted to find Chris out of here for whatever reason? So what we can do is we can do collection equals Kardashians find do person and and the difference between find and find all is find will grab you the first one, find all grabs you all of them. And this one isn't, this one's kind of weird because it's like, yeah, it's just gonna find the one, there's only the one. What we can do is we can add a second Chris in here and it will still just grab you the first one. This isn't that great example, but what we can potentially do, let's throw a Bob in here, Bob Kardashian. Is that a real person or is that like just made up? I think it's
a Robert.
There's a Robert. Oh, go Bob. And let's say I want to grab just the first person whose name has 3 letters in length. And when we run this, it's going to grab Kim and not Bob. So important thing to remember is that find just grabs one person. Find all, not one person. Find grabs the first thing it finds that matches this criteria, whereas find all grabs everything. And if we throw an inspect on here, we can see here that it does not return an array. It returns the string. It returns the one item, right? Because the idea is like, why throw it in an array if you're just going to find the one? Just return the object we're looking for. Cool. All right, it's 9:25. Let's take a Pomodoro break, and we shall return at 9:31.
Thank you, 31.
Thank you, 31.
All right, I think we're all back. So from a discussion in your breakout groups, like we kind of like verified what we talked about map, but Priya, tell me like how does find all work?
Find all is going to run through the block variables, and if the condition matches, it's going to return all of the elements that match that condition.
Cool. And what's the difference between using that and like map to find everything?
Are you still asking me?
Yes.
Okay, sorry.
That's right.
I would say off the top of my head, I'm going to think it has to do with the return statement because .map wants to deal with that like transformed collection, and find all just wants to match the condition and return those.
I think the one thing I want to point out is that when we use map, we will have some nils in our output for things that don't exist. And one method I want to let you know about is flatten. Yeah, which will gets rid of that. Let me make sure.
It's compact.
Compact.
Gets rid of nils.
Thank you. Flatten is when you have nested arrays. Yeah, compact will get rid of nils for you. Cool. Thank you for that. So let us all say goodbye to the Kardashians. I'm so sorry. Goodbye. And we are going to work with something so much cooler than the Kardashians. Numbers. That's fun for everyone. And so I want to introduce you to a couple of this new enumerable. Like the idea here is what do we want to do if we want to get the largest thing out of here? And what we can do is that I want to kind of go through this enumerable and keep comparing it and look until I find the right one. And so what I'm going to do is I'm going to do greatest equals nums.first. And I'm going to iterate through nums.each do. If num is greater than greatest equals num, and this should give me the largest one out of all this, which 9? Yeah, 9. That looks reasonable. 9. And the big picture is I think the thing that is a little different from what we were doing before, we're doing with each, is that we're setting greatest, our outside collector kind of object, to an actual thing instead of an array. Because the thing is, when we're trying to find the largest one, we don't want a collection. We wanted something to compare to, and we are just grabbing one here. We're just grabbing the first item because we need something to compare to. If we don't do this, we have nil, and you don't want to compare a number to nil. That wouldn't be something that works. So again, this kind of puts us this pattern, which doesn't actually kind of work for us, right? In that we're having this kind of extraneous thing. But if we get rid of this, we do have no. Let's do that. And we'll grab us the largest one. And that's 9. I mean, that's a lot better. What do you think that we would type in if we wanted the smallest one? Anyone?
Min,
right? Min. Works the same way. Min. 1. Great. Any questions about min and max? Cool. One thing I do want to note is that you can do a comparison of strings as well. And so if we were to go in our pry here, and we do A is, enter. A is greater than B. Is that a thing that works? What do we think we're going to get if we just ran this? Just don't do it yourself. Just gut instinct. What do you think is going to happen? I see a head shake. Well, what does head shake mean? Does it mean is it not going to work? Are we going to error out? Is it going to give us something unexpected? It's giving us false, and so that means that's weird. So what if I flip this around? Does that mean B is greater than A? True. Okay. And so what we can do then is that we can also run the min on strings like this, and it will find alphabeticalness for us. The idea here is that each string has a numerical value built in under the hood, and what we're doing is comparing that numerical value. It is not comparing like the length of the strings. For example, I'm having mouse issues today. Right, hello, like hi, you'd think like hi doesn't really work because it's shorter, it's comparing like the numerical value.
Mike, I got a quick question.
Yep.
Not looking to talk too much about it, but I'm just curious. Is the built-in value of a string tied to its binary value?
At some point, everything's binary, but what you want to do is like, what I'll do for you is that there's a method that'll give us the string, the numerical value of a string. So we do a.ord, and I think the ord stands for ordinal. And so you can convert, like, so A is going to be 97, B is going to be 98, and that's how we make that comparison. The one thing I want to be careful, you need to be careful with if you're doing stuff like this, is that, so if lowercase a is 97, what do we think uppercase A is going to be?
65.
I mean, 65 was like, okay. So how does that work comparing capital things and lowercase things? Well, you got to think about that kind of situation. That being said, we can also go the other way around. 97.chr will give you the character. Cool. Awesome. So just that's not, I don't usually like converting comparing strings in this way, because it can get real messy real quick if you're not stripping out capital letters. And I want to kind of also mention, it's not also letters that have ordinal values. Every single character available to us has an ordinal value, like period is 46 and so forth. So like that can get good to know, but it can get kind of hairy. Cool. So we also, in addition to min by, max by, let us return to our dear friends, the Kardashians. Oops. And we can also do this kind of comparison by doing this. Oops. See, Chris is the greatest, quotes greatest. And like that's fine, but like what if I wanted to get which one is the greatest by how long their name is, right? So we can do something similar like this. If name is greatest, we could do if name dot length is greater than greatest dot length, right? Because we're now comparing how long things are. And this should be Courtney. Because this is the longest name. I just feel that I'm going to go down this rabbit hole of learning about the Kardashians after this, because I just don't know anything about them. But then again, I don't want to be a person that knows about the Kardashians, so I'm all right with that. And we see that like this is kind of like, this is also the kind of pattern we've seen, like we're having an outside collector with local variable. So we could use max by to kind of like shorten this up. And what we're going to do is greatest equals names dot max by name, third time's a charm.
You're gonna have to change greatest. You have greatest.
Yeah.
Minus.
Cool. And what essentially is saying is like, hey, when we max by something, in the return in the block here, whatever one is the longest, the greatest here, will be selected. Let me save that and run it. Oops. And we get Courtney. And the opposite of this is going to be a min by. And so like this is strings. This is kind of like, yeah, but like how useful is using my strings? And the things that we can do things by objects as well. What I'm gonna do is I'm gonna put this all in one file so it's easier to read. So I have a person object that I'm gonna put in here. Has a name and an age. Let me clean up a little bit. And what I'm gonna do is that I am going to create some people and put them into an array called people. And the idea here is like, what if I wanted to get the oldest person, right? I think that if I were to do this by hand using .each, because I don't know anything about enumerables, we can make a method called def max by people, spell. And we do oldest equals people dot purple. That's great. People dot first, people dot each do person. If person dot age is greater than oldest dot age, oldest equals person, and like so. This is very similar to this kind of pattern we've been doing previously. But we know that like we have max by. So we can make it work in the same kind of way. Instead of doing the creating this method called max by, we can leverage it and be doing greatest equals people dot max by do person dot age. Ooh, that doesn't help us. Let's do greatest dot name. And this should be Scarlet. Scarlet. Any questions about this so far? Cool. All right. So let's take another Pomodoro break. Let's see you back at 10:02.
Thank you, 10:02.
Thank you, 10:02.
And I think the next kind of big thing we want to talk about, this idea of sorting. And I think that sorting is a big computer science topic. There are various sorting algorithms, how we can sort things, but we are not going to go too deep into them right now. Ruby arrays have a default sort method that's just that has this comparison that we're going to go through, and I'm going to do, let's put some numbers, 2, 4, 3, 1. Right, that is out of order. And if we just do a standard sort, just throw on a dot sort at the end, what we get, that does nothing for me. What's that? We run that, we get 1, 2, 3, 4. That is an order. It sort that is ascending order. And for strings, it'll do very similarly the same kind of thing. If we just throw this in a pry for us. Oh, no. Throw a pry, we sort it, it does alphabetically. And I think I want to remind you that when we sort things alphabetically using the sort method on strings, be super careful with capitalization, punctuation. Actually, let's try this. What if we change this to a lowercase m? Will it still work the way we want it to? Yes, let's change this to a lowercase b. That still works the way we want to have. Let us make this lowercase a and make this a uppercase m. you see here that like when we could, you know, configure it this way, like this is kind of not what we expected, right? So like be super careful with when you're sorting strings. And if we have a sort method, and sort kind of works very similar to max and min, what do we think also exists? Carson, what are your thoughts? What also exists?
Sort by max and min.
Right. If max and min work, and we have sort that works, and we have a max by min by, we can probably assume that there's a sort by as well, right? So what we can do is let us return to our friends again. We can use sort by to sort by criteria. I think that's very important to like remember that by really means something. It says like, hey, I want to do this thing as it relates to a certain aspect of this thing. So we can do sorted equals names dot sort by do name. And our criteria that we want to do is name dot length and we do put sorted. We should get this in order, and that looks good. But the question is, what if I wanted the other way around? What if I wanted longest to shortest? Descending? Yeah, descending. There is a way to do that using what's called a spaceship operator. We're not going to go into that now because it's kind of annoying to do. But what I will tell you is that what I will do if I can one day learn how to type, reverse it. And that's just a quick and dirty way, just get the other way around. Also, I want to show you that you can get away with doing this. Throw in a reverse on the dot end like that. And I'll do the same thing. Do this sparingly, like throwing something at the end of a dot end personally. Personally, I'll do this very sparingly, and it'll be like something that's very like simple, like a reverse, something that's very clear, like, hey, the intent of the program is like, I'm just going to kind of swap this around. Any question about sort and sort by now at this point? Cool. Finally, I want to talk about the last class of enumerables are they're very different in that, like, what they'll do, they're what I would call the predicate enumerables. And when I say predicate enumerables, these are enumerables that will return a true or a false. And you can tell that they are predicate enumerables by the fact that they have a question mark at the end of it, right? And an example for this is all question mark. And so what this enumerable does is that if every item in the collection returns true when it goes through the block, the entire method will return true. And if not, it returns false. So I'm going to give you an example here. We're going to give you the coolest array ever. 4 ones, right? Totally cool. Let's do this. We do result equal nums dot all do num, and num equals double equals 1, and let's result. So what happens is that as we go through, if this for every single item in the collection returns true, it'll print out true for us. If any one of them are not, it will return false. So let's run that, and it runs true. If I change this to a 2, it will return false. Another example of this is if, let me grab this, animals. Animals. I was not going to type the hippopotamus out for you. We can do animals dot all do animal animal dot length equals 3. What do we think this is going to return us? True or false? Anyone? Oh, I see some thumbs downs. Yep. Yeah, it's kind of false because like we have the hippopotamus in the room, which is not going to pass this conditional. So knowing about, let's take 5 minutes. Knowing about what all does, what do you think these do? So we want to write you this in a notebook. These methods. Take 5 minutes and write in your notebook what you think each one of these does. And we'll be asking for some of you to share your thoughts on them. So let's take 4 minutes. We'll take 4 minutes. Oh, 1 minute left. Start wrapping up your thoughts. All right, Logan, what do you think any does? When does any return true?
I said it returns true if a specified value is found at least once.
Mm-hmm. And when does it return false?
When none are found.
Mm-hmm. Cool, cool. Philip, what about none?
None.
When does none return true?
It would return true if the specification you give it is false for all
Mm-hmm.
elements.
And when does it return false? I know this one's
It
the
would
hard one
return-
because you gotta like reverse
Yeah.
yourself in your head a bunch.
It would return false if any of them are true of the specified, the specification you give it.
Cool, cool, cool. Corey, what about one?
It'll return true if there's only one
Mhm.
value that matches your conditional.
Cool. Yeah, it's great. I've always felt that like there should be a sum, SOME, and I realized like if like some of them are true, but like then I realized like that's just any, and like why is there some? So they all rhyme. I have a predilection to things that rhyme. Cool. So for the rest of this morning, we're gonna give you some practice. What I'm gonna do is that I'm going to post some code in your channel and give you the opportunity to work through some problems for about 10 minutes. The idea here is that I want you to write code to do these following things. I'm going to break you up into breakout groups to do that. Do not worry if you do not get all of them done right away. This is just more like some practice and be able to some discussion with some of your classmates. So we're going to take about approximately 10 minutes to do this, and I'm going to go back into the same breakout groups, and off you go.
Hey, Mike, I know you're not going to you didn't cover reduce today, but what do you
Mhm.
recommend? I check for, I'm just curious about like how to use it since you guys mentioned it so much.
We'll have an opportunity to do that later on.
Okay.
We'll make some time for
I
it
mean,
somewhere.
I understand it was, I thought it was part of the scope, but I'm happy to go read out.
Yeah, well, I think there's opportunity to do that later. It's not in particular part of this lesson.
Okay, I get it now. Thank you.
Cool, cool. All right, so you have Kat up next. Let's come back at 10:35.
Thank you, 10:35.